Let's solve a cliff problem here. This is red elk throwing a ball off a roof. So let's see. Key here is to draw a very good picture of a building. So this building is 21 meters tall. Red elk is standing on top of there. This is not to scale, right? He throws the ball. Let's assume that the elevation from which he throws the ball, okay, is 21 meters, right? And then this ball lands 17 meters from the base of the building. That's the picture. So this distance here, the height of the building is 21 meters, and then the distance that the ball goes out is 17 meters, right? Okay. Now, with all projectile motion problems, we're going to assume that it doesn't accelerate horizontally and that it does accelerate vertically. Okay. We're also going to assume that he throws it with a purely horizontal velocity. Okay. So therefore, I'm going to say that my initial vertical velocity is 0. And that's what that means, right? I call these cliff problems, right? And then what else do we know? I think the 21 meters here, that's a vertical thing, right? Because that's up and down. But be careful, because from here to here, we go down 21. This is just like those free fall problems, right? So the free fall problem basically is we drop it from here and it falls, right? And then horizontally, our displacement is 17, okay? So what's going to happen here is we can solve the vertical side. Time we'll be able to pull across, and then we'll be able to solve this side. Then let's see what we can answer. Okay. To get the final velocity, I think I'm going to use no t. So I'm going to use Vf squared is Vi squared plus 2ax. Right? So Vf squared is 0 squared plus 2 times negative 9.8 times negative 21. So notice that the negative times the negative makes it positive, which makes it possible for us to take the square root of that. All right, so I'm going to do this times this times this, and then I'm going to do the square root. Okay, so second square root of 2 times negative 9.8 times negative 21, right parentheses. And I get 20 point, the absolute value of the final velocity. Right? Because remember, we square rooted a square. So all we know is that the absolute value of it is 20 I'll say 288. I'm rounding here a little bit, right? Now, I know that it's going down when it hits the ground, right? So this is like one of those free fall problems where we've got to add that minus sign. So 20.288. So we add the minus sign, right? Really, the final velocity is going down. Okay, so that's one thing figured out, right? The next thing I'm going to figure out is the time. Now I could use, I guess, no x to find time. I think I'm going to use my x here because I think it's important to be able to use the height of the cliff to find the time. I'm going to choose this formula. X is VIT plus 1/2 AT squared, right? So minus 21 is 0 times t. Right now, 0 times t is no t at all. I'm just going to say plus 1/2 negative 9.8 times t squared, right? This goes away entirely. Not even the t is left. Just remember that because people mess that up, right? So now I'm typing negative 21 in my calculator. I want to get rid of the 1/2, so I go times 2. I want to get rid of the negative 9.8, so I go divided by negative 9.8. Right, so I did that all. I just typed negative 21 times 2 divided by negative 9.8, and I'm hitting enter. And I get that 4.2857 is t squared. Right, and then how do I get t? Well, I'm going to square root the number I've got there. So I'm going to go second square root, second answer, enter. And I get that the t is equal to 2.070, and then it's like 1966. So I'm going to say 2 because I want to round seconds, and that goes here. Okay, I'm going to store that. In fact, I'm going to store that in t. There it is. All right. Okay. And then that time I can just slide across. So remember that time is always the same. Okay, so 2.0702. Oh, and by the way, just be sure when you're doing the kinematic stuff, only use things on one side. These guys don't mix. The only thing that mixes is the time. The time goes across. Okay, now I'm all set. I'll give you this clue. In the horizontal direction, all you ever do is x is VIT. Okay, it's really this whole formula right here, but there's no acceleration in the horizontal direction. So it's always just this, the first part, VIT, right? Okay, so I'm going to say 17 is the initial velocity, and the final, by the way, times 2.0702. Okay, so 17 divided by the answer I just got is 8.2118 meters per second, and since it can't change, the final is also 8.2118. Okay, and now we're set. I'm going to store that in A, and then let's find that and store that in B. I'm just storing these things in my calculator, right? Okay. Now let's see what questions we've answered. What time is the ball in the air? Well, the answer to A is, if I round that to 3 places, 2.07 seconds, right? What is the final vertical velocity? I guess I'd say negative 20.3, right? So be careful, right? Remember on all these cliff problems, all these velocities will be negative. We start at rest and we always are moving down, right? C says, what's the horizontal velocity? I guess I'd say 8.21. Okay. And now the final thing is, what's the velocity of impact? This is the big thing, right? In terms of an angle and a magnitude. Well, that's this. So what I'm going to do is I'm going to grab this guy. This is my final velocity, right? And really what this is a component vector. This is meters per second in the x direction, and this is meters per second in the y direction, right? So we know how to do this. We learned about vectors right before we did this, right? So let's draw a picture of this, okay? So this is going to be this guy over, okay? So I draw to the right. Right, and this could be this guy down. Okay, now I'm drawing the down intentionally looking longer than the across, because it is. This is actually the velocity, right? So red elk, the ball he's throwing is actually going in this direction, right, when it hits the ground. Okay, and we're just looking at the direction, right? So this is 8, and this is 20.288. Yes. Okay, now I want to find the angle, right? Because we want to make an angle and a magnitude. The magnitude will just be the hypotenuse. Okay, so the angle is, right, theta is the inverse tan, right? We know how to do this, right? Of the opposite, so 20.288 divided by 8.2118. Okay, here we go. Second tan be divided by 67.96. So I guess I'd say that's 68 degrees. Like that. That's my angle, and then my magnitude is going to just be the hypotenuse here, right? So that's going to be the square root of 8.2118 squared plus 20.288 squared. All right, here we go. So second square root, left parenthesis, 8.2118 squared plus, and I get 21.886. And that's the, this is the magnitude of the velocity vector, so I'm going to say 21.9. Okay, This is, by the way, also known as the speed. Okay, so if we said how fast does he hit the ground, or how fast does the ball hit the ground, it wouldn't be this one, it wouldn't be that one, it would be the overall velocity, the overall speed, like that. All right. Yeah, there you go. One more.